Hi, welcome to our pre-calculus. The topic today is solving a triangle with the law of cosines. So, our last lecture we dealt with the law of sines. I have the brief survey of it here. Law of cosines, you see it listed here. I'm also adding something that you can easily extract from properties of cosine function. So you notice that different kind of data that is given to us leads us to use either the law of sines or the law of cosines. Here's a brief survey. If it's angle and side and angle, then law of sines applies and it's straightforward. If it is a side-side angle, the red items are the ones that are given to us. That led to the so-called ambiguous case, which was probably the longest case to consider. If you have all three angles, well, you can get the ratio of the sides. You can get the quantity itself, but you can get the ratio. What we have right now is that if you have all three sides, then that is side, side, side. You can apply the law of cosines to calculate the angles. The angles are the white quantities here. If you have side, angle, side, that is the angle between the two sides are given, very different from this SSA, then you can use this to calculate, you can use the law of cosines to calculate the third side as well as the other two angles. I'm going to go ahead and do several examples, then come and give a brief explanation for where the formulas themselves come from. You might feel a little bit overwhelmed by so many of these formulas, but let me just say that there is really need for remembering one of them. You don't need to remember multiple. Like, for example, when you look at that one, you notice that all the other ones are same as that, except that the letters are rotated. So if instead of A you write B, instead of B you write C, and instead of C you write A, you get the other formulas. Same way here. So this is when we want to calculate the angle, we use this the formula that you see here. But again, if you rotate your letters, you go from A to B to C, and easily you can write the other formulas. These formulas typically don't show up as a main formula in this section, but I wrote it down because it makes our job a little bit easier in some computations. Again, we are going to go ahead and use them and then give an explanation separately. So here I have a first example where we are given the three sides, A, B, C are given, little a, b, c are given. We are also reminded that picture is not drawn to scales. Don't expect the numbers to be related to what you see. We are going to go ahead and calculate the angles. If it is possible, sometimes they might give you sides A, B, C, which does not lead to anything. We are going to briefly talk about that as well. So here you see sometimes no solution. Well, that's a possibility. In this case, if there is a solution, there is just one of them, and then we are going to have just one set of answers to give. So we are calculating ABC, the angles. What do we know? Cosine of angle A. So suppose I am focusing on angle A. Cosine of angle A is B squared plus C squared minus A squared over 2BC. So all that's left for me is to go ahead and calculate the this quantity. I have given the sizes. So I have 67 squared, and C is 74 squared, and A is 46 squared. And then divided by twice B, that's 67 times C, which is 74. So we have to go ahead and calculate this. So a little bit of use of a calculator. In advance, we know that the cosine has to be between 1 and -1. So if this quantity is exceeding 1 or is lower than -1, indicates such a triangle does not exist. You can easily visualize situation that somebody can give you 3 numbers, but those 3 numbers don't necessarily belong to a triangle. So we go ahead and calculate this thing and see what we get. So let's go ahead and crank up our calculators. Okay, so I type this thing on a calculator and I get 0.7915, etc. So now with the cosine function, luckily when we try to find the angle, there's only one angle that applies to us. You remember with the case of the law of sines and ambiguous case, we had the problem that there would be 2 answers, but here there's just one answer. A is cosine inverse of this quantity or that quantity, either of them. You can now if you type this on your calculator, it will be the safest thing to do, because the calculator is going to use its maximum accuracy in calculating everything, and then you don't lose any digits that way. Now the calculation of this my calculator gives 37.669 to 1 decimal. That's going to be 37.7 degrees. Entering these things on a calculator, perhaps the most error-prone section of this whole calculation. Depending on what calculator you use, you have to be very careful with your steps. One of the things to prevent any kind of error or reduce the number of errors is to enclose numerator and denominator in parentheses. When numerator and denominator have multiple terms, if you don't include that parentheses, you might not be getting the correct answer. Or use a calculator that shows how things are typed up so that you can actually see what you are calculating is what you mean to calculate. At any rate, we get cosine of A, and then therefore A itself. Same thing applies to angle B, and we can do the same thing for C, or when we reach C, we can say C is 180 minus A plus B. So sometimes you have multiple ways of calculating these angles, and it makes sense to perhaps make use of the shortcuts perhaps, and variety of formulas that you might have access to, and this is going to give you the confidence. If you get the same answer 2 different ways, it is a blessing that you have multiple checks on your answer. Let me go ahead and double check this thing in your calculator that you have. So let's suppose we use the calculator. So this is a different problem, but that doesn't matter. So we were going to apply cosine inverse of. Then there was a fraction, a numerator and denominator. So I'm going to make a fraction 67 squared, and then plus 74 squared, and then come down minus 46 squared. Now I close the parentheses and then divide by twice times 67 times 74. So you notice that I entered everything in one sweep. Now I go ahead and calculate this quantity. and let's hope that we get the same answer. We notice that we are using degrees, so most of these problems run on degrees, so we don't need to make any changes. And here we got 37.6694, etc. Let's go check if that's what I got on my calculator. Yes, we got this thing before. So you go ahead and continue. So you saw how I typed this thing. I wrap the numerator into a fraction so that it does not get confused as to what is the numerator and what's the denominator. Here's another example. We have, let's write it down what we have here. We have angle B, which is 110 degrees, obviously not drawn to scale, supposed to be obtuse here. A is 46 say meters or something, and C is 31. We want to calculate several items. The items we want to calculate are the angle A, the angle C, and the side B. So let's say the ones that we have are those red items we are given to us, and the white ones are the ones we are calculating. This angle, and this side is what's being calculated. Now we had for B squared is C squared plus A squared minus 2AC cosine of B. So my B squared is therefore this was C and this was of course A. So 31 squared plus 46 squared minus twice 31 times 46 times cosine of 110. So I'm going to go ahead and enter that on my calculator, see what I get. So here I calculated B squared is equal to 4052.44, and then I take square root of this thing, and then what do I get? Square root of this quantity, and I get 63.658, which you are going to round to 63.7. So once we get the angle, once we get the side B, then I have A, B, and C. All three sides are given. I can go ahead and find these two angles just the way we showed in the previous example. We had three sides, and therefore we could get the three angles. Or I can go ahead and apply the law of sine. So we have two options now. In fact, we have many options. Two options at this stage to apply law of cosine again, or we can apply law of sines. If you want to apply law of cosine, well, suppose you want to calculate C. What formula did we have there? We had cosine of C. It was equal to A squared plus B squared minus C squared over 2AB. Now we have our A's and B's and C's. So we have our C. C was 31. So I indicate and leave the calculation for you. So I have A was 46. B we just calculated. Notice this is not a round number or anything. It's just using the approximation. Minus C squared. C squared was 31 squared. over twice A, which was 46, times B, which is 63.7, etc. Now at this stage you better have the accurate number, 63.658. So we write that, and that better be used in these two spots so that we don't lose accuracy. Then we can calculate C by cosine inverse of this number. Cosine inverse of whatever this fraction is, it can be used from that one. Or you can apply, and same way you can apply this same approach to calculate cosine of the other angle. The other angle that we are missing is the angle A. When you want to calculate angle A, you do the same thing here. So you calculate cosine of A, and then you find the A again by cosine inverse. Okay, so we can apply the law of cosine to calculate, say, cosine of C and then get a C out of that, and similarly apply same law to get angle A. I'm going to go ahead and explain so-called simplified law of cosine. That makes the calculation a little bit easier than this. You still have the option of going do law of sines. That's explained in your software and is very similar to what we have done before. One minor thing with respect to law of sines is that there's always that ambiguity situation, and then you have to choose between two possible angles. So in order to avoid that, I'm going to go ahead and explain a so-called simplified law of cosines. So for example, suppose I want to go after the angle C. Now I have the following: cosine of C is equal to B cosine of excuse me, let me rephrase. Simplified law of cosines. One of them is A is equal to B cosine of C plus C cosine of B. Now, of all of these quantities at this stage, I have everything except cosine of C, and that's why I'm going after this particular formula. So my A is 46 and my B is 63.65. What did you have? 658. So we can't avoid that strange number there, times cosine of C that I want to calculate plus C. C was 31. Cosine of B is also given to us, is 110 degrees. So we are going to go after calculating cosine of C. How do we do that? Calculate this thing and move it to the left hand side. So I'll have 46 minus 31 cosine of 110 degrees is equal to 63.658 times cosine of C, which tells me cosine of C is equal to 46 minus 31 cosine of 110 over 63.658. Again, the advantage of going about it this way is that when you calculate C from this formula, there is no issue of any ambiguity. You have one angle, and if you can calculate it, all is set. So here I go ahead and try to find this thing from my calculator. Let's see. So I get 0.889, etc. That is for my cosine of C. and C becomes, let's do inverse cosine of this. Let's see, it becomes 27.2 degrees. In the same fashion, we go ahead and calculate angle A, and I leave that to you. Now let's go ahead and to the beginning to see where did the formulas themselves come from. So we have law of cosines and the simplified law of cosine, and let's see the derivation of these things. Okay, first we want to explain where does the law of cosine come from. So let's take a triangle. Let's call this thing C and say this is A and this is B, and so this is little c and B and A. I draw the perpendicular here and call this thing H, and this side X and this side Y. So by now we are familiar that H divided by B is going to be sine of C, so H is B sine of C, and X similarly is B times cosine of C. So we remember that from solving right triangles. Y, of course, then Y is going to be A minus X. Now what I'm going to do is to go ahead and take a look at this right triangle here. What can I write there? Right triangle, I can write C squared is equal to H squared plus Y squared. So C squared is H squared and Y was A minus X squared. So let's square that. I have A squared plus X squared minus 2AX. Now let's rearrange this thing. C squared, I put H and X next to each other, and A squared minus 2AX. H squared plus X squared, of course, is just B squared. And I had A minus 2A, and X itself was B cosine of C. B cosine of C. So here's the law of cosines. So what did we do? Law of cosine. I applied the Pythagorean theorem once to this triangle, the second time to this triangle. Out came the law of cosine. Now you can take this thing and rearrange it. For example, I bring this minus term to the left to AB cosine of C, and take C squared to the right, so I'll have B squared plus A squared minus C squared. I divide both sides by 2AB, so what do I get? B squared plus A squared minus C squared over 2AB. So these are the two forms of law of cosine. If you want to find the side, that's what you use. If you want to find the angle, this is what you use. Next, how about simplified law of cosine? Again, let's just go ahead and prove one case of this. So let's have for example, little c and A and B and A, and this is going to be angle B. Again, I drop this perpendicular. Let's call this thing X and let's call this thing Y. As before, we noticed that X is A cosine of B. Y is B cosine of A. Now what is x plus y? X plus y is just c. And so c is just a cosine of b plus b cosine of a. And that's the simplified law of cosine. We have three forms of it for each of the each of the sides. You can write it for a or b or c, it's all same. And this is what we wrote here as let me indicate it here, simplified okay. So we dealt with the issue of applying law of cosines in a variety of ways. We said an advantage of cosine is that we don't have the issue of ambiguity anymore, or whatever angle we get, there's just one of them, and that settles the case. We don't need to worry about an alternate case and choosing one of the two. Other than that, both of them are equally easy to use. Until next time, good luck and God bless.